Hello students, this is the section Sampling from the chapter Basic Ideas. In this section, we go over how to construct a simple random sample, how to determine when samples of convenience are acceptable, describes stratified sampling, cluster sampling, systematic sampling, and voluntary response sampling. We want to also be able to distinguish between statistics and parameters. Let's start first with the definition of statistics, which is the study of procedures for collecting, describing, and drawing conclusions from information. There is a investigative process for statistics. First, we start by formulating a question. Then, in an attempt to answer that question, we're going to collect data needed to analyze it, and eventually we're going to be also describing the data collected. We're going to draw conclusions using appropriate methods depending on whatever question you formulated and depending on the type of data you collected, and also depending on the statistic procedure you followed to analyze it. If you're able to answer the question, then your investigative process is over. If not, you have to start over again. Maybe reformulate the question or recollect data to answer the question. I would like to go over some terminology. If we're having a large group of individuals and we want to collect information for the whole group of individuals, it's going to be hard. Instead, we collect information from a small part of that large group. In statistical words, we call the large group population and the small group that we collected information from the sample. Which takes us to our next definitions. A population is the entire collection of individuals about which information is sought, and a sample is a subset of a population containing the individuals that are observed. Think of the population being let's suppose that I'm collecting information about teachers all over the world. My population will be all of the teachers all over the world. You can choose which one's your population. It doesn't have to be over the entire planet. It could be of a city, it could be of a state, it could be of the country, or even your population can be as small as a campus. It can be the population you decide to study could be just the teachers at a particular high school or a particular college campus. A sample is a subset of that population. So if you're talking about the teachers all over the world, a smaller number of teachers than the ones around the world is considered a sample. If you're talking about the teachers in a campus, let's suppose a high school, a sample could be one teacher of each subject, one from math, one from science, one from Spanish, and so on. You determine which one's your population and you determine how to collect your sample. We use this method because it will be really, really hard in some cases to study the entire population. Let's suppose we want to study, I don't know, which kids in the US country are diabetic. It will be really hard to survey all of the kids in the entire population of the United States. It's doable, it's feasible, but it could take too long, and the information could be also not as accurate as we want it to be. Instead, we collect a sample, we study those individuals from our sample, and then draw conclusions about the population. We're going to cover a variety of sampling methods in this section, like the stratified sampling, cluster sampling, and so on. Disclaimer: no sampling method can guarantee that a sample will represent the population well. Think of all those unique individuals that have specific characteristics or do not fit the model or the more common characteristics of everybody else. Our first sampling method, it's called simple random sampling. A simple random sample of size n, take n to be any number, is a sample chosen by a method in which each collection of the n population items is equally likely to make up the sample, just as in the lottery. I don't know if you have ever heard the example of put all the names in a bowl and then randomly pick them out, or in a bag of marbles, you mix them up and without looking, you take out a ball. What color would that ball be? All of those are examples of a simple random sample. We can, I guess the easier way to do a simple random sample, collect a simple random sample, would be by doing so, putting the names in a bowl and then mixing them up and without looking, taking them out. Or you can use a sample generator. There's a lot of online websites that you can put names, or you can upload a data, a list of names or some data, and you can collect a sample, or you can generate a sample with that website or application. Let's take this next example. If you need to, pause the video and try to assess yourself. I'm going to read the question and then, of course, go over the answer. Is this sample a simple random sample? Mrs. Sanchez-Cortez wants to draw a sample of 30 students to fill out a questionnaire about which sports they play. Her Monday morning class has 30 students. She uses the first 20 minutes of class to have the students fill out their questionnaire. Is this a simple random sample? Feel free to pause the video and then listen to the answer. In this example, we're not being specific about which one's the population. It just says that she wants to draw a sample of 30 students. Given that she doesn't say that the population is those 30 students, we can already say that this is not a simple random sample. Whether her population was all of the students from her classes, or all of the students on campus, or all the students that belong to the school district, her Monday morning class, it's a very particular set of students. All of them are taking this morning course. All of them are taking a morning class. All of those students do not work at that particular time, or do not, or maybe are full-time students. It's not random. The students from her afternoon class, the students from her Tuesday class, the students from her Friday class did not have the chance to come up in this sample. Remember, as part of the simple random sample, each item in the population is equally likely to make up the sample. Since that's not the case for her other classes or for the other students on campus, this is not a simple random sample. And here's the answer. No, because the students who are not in Ms. Sanchez-Cortez's class had a chance to be part of the sample. It will be did not have. Oops, sorry. Did not have. All right. Let's look at another example. Is this a simple random sample? For the Mega Million game, you must select 5 numbers from 1 to 70 and 1 number from 1 to 25. This is 70. A perfect match will win the jackpot. I don't know if you guys played lottery, but these are the rules. If you choose the number 1, 2, 3, 4, 5, and 6, is it very unlikely that a random sample will turn up the first 6 numbers? Think about it. In this case, this is just this number 1, 2, 3, 4, 5, 6 is just as likely as any other number, or just as unlikely as any other combination of 6 numbers. The reason why is because every collection of 6 numbers is equally likely to happen. So if you choose the numbers 1, 2, 3, 4, 5, 6, you have the same chance as anyone else playing to win the jackpot. because it could have been the number 1, 2, 3, 4, 5, 6, or 1, 2, 3, 4, 5, 7, or 1, 2, 3, 4, 5, 8. Each of the combination of numbers, assuming that the order does not matter, it's equally likely to happen. All right, let's keep on practicing. Is this a random sample? Target, the store, wants to estimate the proportion of Americans in San Antonio who like blueberry flavored ice cream. So they go to the largest target and approach people to ask whether they like it or not. If you want to, pause this video and reflect on the situation. Because it says that they only interviewed people at one or the largest target in San Antonio, then this is not a simple random sample, because the people that visit the other targets are not equally likely to be part of this survey or this questionnaire that they're conducting. Since they want to estimate the proportion of Americans in San Antonio, yes, it's true they're in San Antonio, but they will have to go to all the Target stores. And it doesn't say particularly Target customers. So the people that go to Walmart, the people that go to H-E-B did not have the chance to be in this survey or in this sample, which means, again, this is not a simple random sample. Here's one more example. Spectrum wants to estimate the proportion of customers who are satisfied with their service. They use a computer to generate a list of random customer phone numbers and call those people to ask them whether they are satisfied or not. Pause this video and reflect on this situation. Because they used a computer, and because they're also talking about their customers who are satisfied with their service, then yes, this is a simple random sample. If they had said all of the Americans, then this would not be a simple random sample, because the customers that do not have Spectrum would not be equally likely to appear in the sample. But because they're only focusing on their customers and they use a simple random sample generator, then yes, this is a simple random sample. Let's go to our next sampling method. A sample of convenience. It's a sample that is not drawn by a well-defined random method. Here's an example. A construction engineer wants to investigate the crush strength of the blocks from a shipment of 1,000 concrete blocks. Each weighs 50 pounds. A sample of convenience would be him grabbing only the ones that are more accessible. Instead of choosing at random out of those 1,000 concrete blocks, he just grabs one portion from the corner, or one portion from the side, or one portion from the top, because they're too heavy to be either putting in a bowl and scrambling them and then pulling them at random, or choosing from the very middle of the shipment. This will be a sample of convenience. It's convenient for this engineer to only test the crush strength of the blocks from one side or from one corner. The big problem with this sample of convenience is that they may differ systematically in some way from the population. These are only used when a random sample is not feasible. When you cannot conduct a random sample in the example, like in the example of the blocks from the shipment, it would be a good idea to do a sample of convenience. Okay, let's move on to a next sampling method, stratified sampling. The population is divided into groups called strata, where the members of each stratum are similar in some way. Then a simple random sample is drawn from each stratum. Useful when strata differ from one another, but the individuals within a stratum tend to be alike. I don't know if you have seen those surveys where they ask you select your age group. Then those could be called the stratum or the strata. And then from each category, from each age group, they conduct a simple random sample. Let's suppose that we're talking about the kids in the US, remember? Or the kids in I don't know, a particular school, whatever your population group you want to. You can divide your group into, you can divide your group by gender. It could be boys and girls. And then from the group of the boys, which is our strata, you conduct a simple random sample. And then from the group of the girls. This is called stratified sampling. Here's an example. A college has 1,000 employees, 800 full-time and 200 part-time. The company wants to survey 50 employees about their opinions regarding benefits. Attitudes toward benefits may differ between full-time and part-time employees. Why might it be a good idea to draw a stratified sample? Well, think about it. The full-time employees are receiving benefits or full benefits, but the part-timers are not. They may be receiving some benefits, or they may be receiving no benefits. Of course, their opinions are going to be different. That's why we would like to cluster them. We would like to cluster the full-time employees and the part-time employees, and then from those draw a simple random sample. Because we know our opinions, their opinions, are going to be different, or their attitudes are going to be different depending on their full-time or part-time position. Our next sampling method is called cluster sampling. Items are drawn from the population in groups or clusters. It's very useful when the population is too large and spread out for random sampling to be feasible. And the perfect example for cluster sampling is the census. They go, and from each household they survey people, or they collect data from a sample of the population using cluster sampling. There's another sampling method that is called systematic sampling. The population items are ordered, and it is decided how frequently to sample the items. For example, every third item, every fifth or 100th item, or so on. I have only seen this in movies, but whenever they're checking cars, not only in the movies, only in the movies, in the highways, or randomly in the streets, but in the border, whenever you're going to cross from Mexico to the US, they check cars, and it's a random, unless you raise a flag, or unless your documents are not in order. They randomly choose how many cars they're going to forcefully check. I don't know, every third card, every fifth card. And our last sampling method is called voluntary response sampling. In a voluntary response sample, the population, I guess, would be sent a survey or whatever you want to assess, and they decide whether or not to participate. Voluntary response samples are never reliable, because people who go to the trouble to volunteer and give their opinion tend to have stronger opinions, whether it's a good opinion or a bad opinion, than it would be for the other interviewees, I guess. So we covered voluntary response sampling, systematic sampling, which is every third, every fourth, every fifth, cluster sampling, where your population is already clustered in groups and you sample out of those groups. We covered stratified sampling, where you purposely, depending on their characteristics, cluster your population in groups called strata. These groups are called strata. We talked about sample of convenience, when the simple random sample is not feasible, and the simple random sample. Finally, let's close with those parameter and statistic definitions. A parameter is a number that describes the population. A statistic is a number that describes a sample. So out of the data collected, if your data is from the population, we call that parameter. If your number or if your data describes the sample only, it's called statistic. A remembering trick, parameter starts with P, just like population, and statistics starts with S, just like sample does. And to finish, let's practice identifying which one's a parameter and which one is a characteristic. You can pause this video and read these and then practice identifying which one's the parameter, which one's a characteristic, and then you can just continue watching the video and I'll help you answer these. Number 1, the total number of cars owned by all families in a neighborhood. Number 2, the average height of a sample of 50 students from a specific school, the average score of a sample of 30 students on a math test, and the average income of all households in a country. The key words of these, remember, you decide which one is your population and you decide how you're going to sample out of that population. But your population could be as small or as big as you desire to be. So, because of those keywords, all, sample, or the entire group, we can identify which one's a parameter or a statistic. Number 1, the total number of cars owned by all families in a neighborhood. Because we're talking about all of the families, then we can say that will be our population. In that neighborhood, all of the families. That's a population, which means this will be a parameter. Number 2, the keyword is samples, so that one's a statistic. Number 3, again, the average score of a sample of 30 students on a math test, that will be again a statistic. And finally, the average income of all households in a country, because it says all of the households, this would be a parameter since it describes our population, which in this particular example, number 4, it will be all of the households in the country. Thank you for watching this video.